Hello, we are from Turkmenistan. Our project is combined solar distiller. As you know, there are lots of methods of desalination, but we suggested the new method. The innovation relates to a device that can produce pure marine or industrial water and use it as a drinking water, as well as for domestic use by the staff residing near the drilling sites in deserts. There are some ways of desalination. First, solar desalination plant containing. Second, solar desalination plant comprised of, and another known desalination contains. All of them have their own drawbacks. For example, solar desalination plant comprised of. This model's disadvantage is low productivity. Also, solar desalination plant containing models disadvantage is potential high cost. We considered all of drawbacks of models and suggest our model to use it as a usable way. Now my friend will tell purposes.
Thank you, my friend, and I will explain you aims of the project. First, to increase the efficiency of solar distillers. Second, to eliminate drawbacks inherent in the similar devices. Third, to reduce the cost of construction by using relatively cheap materials. And fourth aim, to diminish the harmful effect of exhaust gases emitted from internal combustion engine, using those gases as a heat of source for evaporation of water. And the fifth aim is to use the solar energy as one thermal source. And the last aim of our project to present advice that can work not only during the day but also during the night hours and the day with low solar light. This is our proposal which I counted upward.
And let's introduce to you with working process of our model. Procedure. Process water from the rig is collected in a tank. Next, it's fed into the tank, which is initially heated to the temperature allowed by the internal combustion engine. The hot coolant from the active engine cooling system of ICE gives thermal energy to the original salt water through the heater in a thermal insulated container and returns cooled to the internal combustion engine. The water level in the tank is lower than that in the tank. So the water is fed by itself to reservoir through the pipeline. Regulation of water transfusions is implemented by the float valve, which maintains constant water level in the tank. The water level in the latter is higher than that in desalinator. Consequently, the desalinator is filled through with a check valve. Water transfusion in evaporator does not occur, and the support of constant water level is maintained by means of the annular float. As the evaporator is filled, the annular float also rises, and upon reaching the maximum water level, the reverse valve is closed, due to the fact that the latter is rigidly attached by means of rods to the annular float. The radiant energy of the sun falls on the surface of the translucent solar water heaters and hits the salt water in them, and the hotter part of it flows through the outlet into the interior of the upper water pipe. The same process occurs in all parallel connected solar water heaters. The heaters, despite their immobility related to the sun, absorb the optimal level of radiant energy because they are mounted on the east-west axis with a focus of light receiving surface to the south and the optimum angle of inclination of zenith alpha. For example, alpha equal gamma minus 9 degree. These translucent surface on the solar water heaters do not fog up, which helps to maximize the passage of rays. The maximum surface absorption and transmission of thermal energy from the sun to the salt water, raising the temperature of the latter. Exhaust from the operating engine enters the cavity walls Why thermally insulates gas pipe? The water previously heated by gas line, steam pipe, and the water heaters is heated to a high temperature. It finally boils and turns into steam. Next, the exhaust gas pass through the pipeline and by heating it, gives thermal energy to the salt water located in the inner cavity of desalinator. Open the exit, they also rotate the drive wheel of the low pressure microgas turbine due to the compressed exhaust energy of the internal combustion engine. Thus, while rotating the wheel, injects steam into the heat exchanger through the steam line, sucking it from the interior of the evaporator, which reduces the pressure in the inner cavity of the latter, which in turn leads to lower boiling temperature, increased vaporization and release of the distillate. Steam line heats salt water that is located in the inner cavity of the distiller, giving it heat energy of the steam. The vapor is gradually transformed into a condensate as it passes through the steam line and into distilled water via the heat exchanger. Finally, the distillate flows into a tank for collecting the distillate. Annular float mounted in the tank for collecting the concentrated solution. Intermittently removes the final brine in expedient to further evaporation. The process occurs due to the high density of the brine as the annular float emerges only with a liquid with high density. The brine, having a higher density relative to the original salt water, constantly tends to pass to the lowest point of the distiller and then to a tank for collecting the distiller, given the heat energy as it goes. The brine finally flows into the drain. Thanks to the optimal slope of the water pipes and title of the solar water heaters, to the zenith alpha and the placement of the evaporator at the top and containers for the collection of the brine in the bottom, there is a natural circulation in the inner cavity distiller.
And now I am going to explain you the results of our project. The transition of the hottest part of the salt water into the evaporator, where the temperature is the highest, evaporation of water, and removal and collection of the brine in a tank. All occurs under the laws of physics, namely one of the physical parameters such as density, which generally leads to optimizing the use of thermal energy, increase the yield of distillate, reduce the emission of the heat environment, and improve the efficiency of the plant. The combined solar distillers can operate at its full output level during all the daylight hours. However, the sun is only one of the heat energy sources. Consequently, the plant can work during the night as well. Physical, technical, and thermodynamic studies underline the operation of the device work well confirmed. The device is free from the drawbacks found in the device with similar purposes as discussed above, and requires no special training in its use.
Thank you, that's all. See you soon.